Alright students, so welcome back to another banger tutorial. Maybe let's call it a banger video lesson. Yeah, so in this video I'll be solving some tutorial sheet questions in tutorial sheet 5 on quadratic equations. Okay, so these are the questions that we're going to solve. We're going to look at different methods that you can use to solve a quadratic equation where we're going to solve questions involving completing the square method, factorization, and the quadratic formula, and also we're going to look at how we can apply the concepts of discriminants, okay, discriminants of the roots in the questions that are in the tutorial sheet. So we're going to look to solve from question 1 to question 5. Okay, so this video we're going to focus on this part. I know maybe the video is going to be quite long, but just take your time and follow along while I solve. And the continuation video, this video is part 1. Part 2 video is there on the A+ Academy app. Look, this video will be focused on solving, not teaching. Okay, I'll be applying all the knowledge that has been taught in the video lessons that are there on the A+ Academy app. Our app right now is on Play Store. I'll put the link in the description or in the comment section so that you can have access to the app and download the lessons. Okay, I repeat, don't expect me to teach. I'll be just solving. I'll be applying the concepts that have been already taught in our video lessons on the A+ Academy app. So I hope that you enjoy this video, and in the part 2 video that will be on the A+ Academy app. This is part 1 video on YouTube. So part 2 video, I'll continue solving questions, continuing on the roots of quadratic equations and the polynomials. Okay, of course maybe I might not solve all of them in one video, but I'll just pick those important questions in the part 2 video. Alright, so without any further ado, let's proceed and solve the questions. Plus app. This is where you access all the full videos. So what you just do is come here on videos and then click on term 1, term 2 or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions. If you haven't understood everything that we've learned so far, or that we're going to cover in the video. Okay, so all these topics, okay, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are. Then you catch up at the end of the day. And we have a lot of students who are watching these videos and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. You're going to find videos about it. Okay, but it's not only math, even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just choose CH110. You find the videos here. Okay, if it's introduction to chemistry, you'll find the videos. So all these topics have been taught. Alright, so it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A+ Academy app and start learning and practicing with our solved materials. Alright, so let's solve the first question. So the first question is saying that use completing the square method to solve the following quadratic equations. So completing the square method is a method which you can also use to solve a quadratic equation. Instead of using the base formula, it's not only the base formula that you can use, okay? In case you didn't know. If you don't know the base formula, maybe you might find this one to be easy, okay? Yeah, so you can also use completing the square method. The same completing the square method that you use when you are graphing. I mean, when you are finding the turning point, when you're answering those kind of questions, we can use it as well to find just the values of x. Just that we do it differently, but the initial steps for the procedures are the same. Okay, so I want you to pay attention. Right. So, and I repeat, this video I'm recording, it is just for solving. I'm applying the knowledge that I've already taught in the videos found on the A Plus Academy app. So make sure that you subscribe to A Plus Academy app. You'll find the lessons where I teach from basic to advanced, to make sure that you reach at a point where you can also solve the auto sheet. Yeah. And it's in the B. Okay, let's first solve question 1A. We just solve this. Maybe I'll also leave one for you. Okay, you just have to get the concept. Okay, so when you're using completing the square method to find the value of x, this is how you approach it. Okay, so look, we have a quadratic equation. A quadratic equation, it comes in this format, right? I want you to pay attention here. So where this a, b, c, we have numbers there, right? Okay, so what you do is that whatever is a is usually a constant, right? Not say always a constant. It is, I mean, let me not say it is usually a constant. It is always a constant, like it does not have x. Yeah. So whatever is here, you take it on the other side. Alright? So this number here in this situation is presenting c. So let me just write it again. We have x power 2 minus 4x minus okay, so say is equal to, so this thing here, we are going to take it on the other side. So we're going to take it on the other side where this 0. So when 13 goes on the other side, it's going to be, so always if you're solving the quadratic equation using completing the square method, you need to take what is here on the other side. And then after you do this, you are going to get what is here, which is negative 4 multiplied by 1 over 2, which is going to give you negative 2, right? Okay, so now remember we are here. So what I would do is that this negative 2 that I've gotten, after multiplying 1 over 2 to the coefficient of x, this negative 2 here, I'm going to add it on this side and on this side, but I'll raise it to the power of 2. So that's step 1. That is step 2. So step 1, take the constant on the other side. Step 2, after you find this, so first I'm going to write what I'm having initially. Then I'm going to add this one, but it will be raised to the power of 2. Even on the left side, we have 13. I'm going to add negative 2 raised to the power of 2. Makes sense, right? So now, I'm going to remember what we do. Since this and this, they are both raised to the power of 2, so they have something in common, right? So you can put them together, x and d negative 2, because both of them are raised to the power of 2. So we can put them in the same parentheses and raise it to the power of 2. And we can just ignore this one now. It is now out of sight, out of mind. Okay. And then, what have I remained with here? So we're going to simplify it a little bit. I have 13 plus negative 2 raised to the power of 2. That will be 4, right? So 13 plus 4, that will give you 17, right? So I have, this is also completing the square method. I know maybe some of you just memorize steps, you might be confused, but how is it different from the one that we use? If you try to observe, the principles are just the same. So that will be 17, right? So now, how am I going to find the value of x? I'm going to square root both sides. Introduce the square root on both sides. Now, if you introduce a square root, you're going to end up with plus or minus. Whenever you introduce square roots on both sides, when you're solving for x, this other side, you introduce also plus or minus, so 17, right? So this square root will cancel with the the power 2. and I'll remain with x minus 2 plus or minus square root of 17. So this negative 2, I'll take it on the other side, and it will be plus 2, right? So the possible values of x can either be negative 17, negative square root of 17 plus 2, even put it in the brackets like that, or let me say or the value of x is equal to positive 17 plus 2. So one of these two, right? Remember, it's a quadratic equation. The answers need to be 2. So for you guys who are doubting, try to use that bus formula that you use. You'll find that you still end up with the same answer. So the good part of using this one is that if you're using that bus formula, which is like negative b plus or minus b squared what, you know what I'm talking about, right? That one, you need to memorize the formula. So if you're someone who don't know how to memorize the formula, but you can memorize these easy steps, just be using this one. Unless they have specified that use the quadratic formula, that's when you can use this thing we call the bus formula. Okay, so let's move on to the next question. I think the next question I'll give you, you try it. Okay, you try it out. Then I'll solve question 3 because let me show you. So this one you're going to solve to be your homework. I want you to comment there in the comment section. Comment what you get. This one I'll solve it because of having a negative in front. So this one maybe might be tricky, but this one they have done it for you. The 7 they have taken it already on the other side for you. So it's now up to you to finish it. Alright. So this is your homework. Now this is the one I'm going to solve. I want you to comment, solve this one, and give me the answers in the comment section. You need to participate. Okay. Negative x power 2 minus 6x minus 7. Alright, so now let's quickly solve this one. So how do you think we can solve this? So what I'm going to do is this. I'm going to divide through by a negative. Why? Because I don't want to have anything in front. So I'll say over negative 1 over negative 1 over negative 1 over negative 1, and I'm going to end up with x power 2 plus 6x plus 7 is equal to 0. So 7, I'll take it on the other side, and I'll have negative 7, right? And then I'll get the coefficient of the value having only x, which is 6, then I'll multiply it by 1 over 2. This is going to give me 3. Okay, so this 3 that you're seeing here, I'm going to raise it to the power of 2 and add it to the left and right hand side. So we have x power 2 plus 6x. I'm sure by now you've understood how I explained on the first question. If you were not clear there, I'm sure on this one you'll be 100% clear. Okay, so we have x power 2 plus 6x. Then I'll say plus this one which I found here, 3, but I'll raise it to the power of 2. Then I'll say equal to negative 7. So even on this side, I also add 3 to the power of 2. So don't forget, this one, raise it to the power of 2, then add here and here. Okay, but don't rush to simplify, especially if you're adding on this side. Don't do that. No, 3 power 2 is 9, you write 9. No. Okay, so since x power 2 and 3 power 2, like these two, they are raised to the power of 2. They have something in common. We can put them together in the parentheses, which is actually these, we call them parentheses. Especially for you guys who have done programming before. Programming, you're going to do it, I think you're going to have C++. Yeah, these are called parentheses. This symbol. Okay, so I'm putting them in parentheses. So we have x plus 3. These positive 3 and x, they are both raised to the power of 2. So that's why I am putting them in the single parentheses and raising them to the power of 2. Then here I have negative 7 plus, what is 3 power 2? 3 power 2 is 9. So this is negative, this is positive. If we sum them up, we're going to get positive 2. Because this one is positive, this one is negative, this one is positive. But if you know the number line, you know why we're doing this. 3 I don't have to teach you the number line, guys. These concepts should know them by now. You are grown-ups now. Okay, part 2. So it's the highest time we introduce the square root and also plus or minus. Alright, so this square root will cancel and I'll remain with x plus 3 equal to plus or minus square root of 2. Alright, so I'm going to take this on the other side and I'm going to have x is equal to plus or minus square root of 2. This one is going to go on the other side and I have negative 3. So x is equal to x can either be this or x is equal to so these are the possible values of x. Okay, so let's go to B. This is where the drama is. Like, in that solved tutorial sheet that I sent, actually I've solved the whole tutorial sheet. It's there on the A Plus Academy app. To contact me, make sure I'll put my number on the screen or in the comment section there. If you don't have the app, where I post the solved tutorial sheet, like I solved them by writing. There are some people who can't manage to watch the whole video. I know the video maybe might be 1 hour and above, but like some people can't manage to revise by watching. There are those who would rather read. They solve, they compare with my solutions. I've already solved, unwritten solved document. It's there on A Plus Academy app of tutorial sheet 5 in these other tutorial sheets. Okay, so now like when I uploaded, some people didn't understand how I was solving this, like the logic. So I want you to pay attention. This part is tricky. Okay, so the way that let me first read the question. They're saying that solve the following equations by factorization method. If they want us to use factorization method, I know what you're thinking now. Well, you just find what is common on this side and the other side. Yes, you are right. But if your equation is having from a square root, this is square root. If you just see that they have combined these things having square root, the game becomes different. Okay, the way we approach them becomes different. I'll show you what I mean. Of course, we are going to use the same procedures. Okay, let me start. I show you. Alright, so listen. Just because I've said that it's different, I don't mean that everything, no. But like, there's just somewhere where we do something different whenever we are having from a square root. Okay? Of course, we use the same procedure. Find the product. Product is when you multiply this times this. So again, this type of equation, if you don't understand the rules of multiplying radicals, said those steps, if you don't understand them, again, you'll be confused. You'll be like, where did you get that number? I'm sure some people are coming in my DM. Where did you get that number? So what you do is you multiply what is here and what is here, right? So we basically do square root of 2 times 5 square root of 2, right? So remember, if you're multiplying the radicals, if these two square roots are the same, what do? This use... Okay, look, here in front, it's like there's 1. Am I right? I mean, yeah. Why does it seem to be there? Alright, so I'm saying here in front of this square root, it's like there's 1, right? So you're going to say 1 times 5. You multiply those that are not the square roots. It is just going to be 5. Now we come to the square roots. This times this. First we multiply this times this. Now we come to the square roots or to the radicals. Now since both of them are square roots and they are having the same number under them, the square root will just be cancelled. Okay, the square root will be just cancelled and get back the number that is under them, which is 2. If you don't understand this, first of all, if you haven't subscribed to A Plus Academy, I think there is a video here where I was showing out to rationalize. And I recommend you just subscribe to A Plus Academy app because I've taught these things from scratch. This video, I said it is focused on solving, though I'm trying my whole level best to explain a little bit, but I won't maybe explain as deeper as I might want to explain in the full video lessons found on the app. So go on the A Plus Academy app under the set, I think, under the set theorem, you find videos titled radicals. Go and watch them from the beginning, from the first video to the last video. I've explained this. So when you multiply, you're going to end up with this, which when simplified will give you 5 times 2, it is what? 10. I know if you haven't understood, don't comment in the comment section like, how did you get that 10? The reason why you're asking is because you don't understand radicals. So go and watch the videos. The rules of multiplying radicals. You need to understand that. Okay, so what's the sum? Sum is what is found here on this one. The coefficient of this value, which is 7. Okay, so I know my product is 10. My sum is 7, right? Now I need to find the factors. I need to find a number which if I multiply, I need to find two numbers which if I multiply them, they'll give me 10, and if I add them, they'll give me 7. I want you to think. So these numbers will be 2, 5, 2 and 5. When we add them up, they'll give us 7. When we multiply them, they'll give us 10. Okay, step by step. Okay. And then, so now we know the factors. Let's do what we do. So first I'll get this one, right, which is square root of 2 x power 2. Then I'll say plus one of the factor, I'll get 2 x, right? Then I'll say plus 5 with the factor x. Then I'll say plus this last thing here, which is 5. Same procedure. The only different thing right now is that this time you're having radicals. Now I'm about to show you a step which is tricky. If you miss it, then you'll be lost. Okay, I want you to pay attention. So when you reach at this point, what do? We kind of like group them, right? Is this what we do? We like group them. Then we start finding like, okay, in the first group, let me just show the parentheses. The reason why I'm grouping is that I want you to understand. Okay, so I'll start with these. What is that thing that is in common, that is found on this side and the other side? You just do the same thing that you do when you're... Alright, so now I want you to pay attention. So you know that after a group, then you are going to factorize like each group, this part and this part, whereby you say what is in common, what is found on both sides, this side and this side. X is in common here, right? You factor it out. Then you say, what if we factor out x, what will remain is square root of 2x plus 2. That's what we do, right? Now, when you are dealing with this one, this type of equation whereby it is having radicals of square root in it, it's different, especially on this stage. Of course, you have to do this, what I've done here. But when you come to the other one, you do things differently. So, I know what you're thinking, that okay, since 5 is common here, we can factor out 5 and we remain with x plus square root of 2. I'm sure that's what you did. But no. Of course, you only need to do this for the first group. Look, I've divided this one in two groups. This the first group and the second group, right? By using these parentheses. So you don't do this for the second group. You don't use this method. You only use this method for the first group. Don't do this. This only applies when you are having square roots. That's what I don't know how many times I'm going to say this. I don't want you to use this method when they give you just a standard one, an ordinary quadratic equation. Don't think of doing this. Right. This is factorization method. Don't go and use the bus formula. No, I know it can work, but don't use it because they have specified that use the factorization method. So now what do we do for this group? So for this group, you're going to find, okay, let me come back here. Have you seen, here is x, right? X is the value that has been factored out. So here what you're going to do is that for this other group, which I've grouped here, you're going to find the value that will be factored out. Yes. For that is going to be outside when we factorize. Now, how do you find that value? So what will help you to find the value that will be outside or that will be factored out is this thing here. Have you seen? Look, the reason why I said this is wrong is because whenever we do this, what is here and what is here should be the same. Now if you try to compare, here we're having square root of 2x plus 2, but here we're having x plus square root of 2, which is wrong. Whenever you're using factorization method, this is wrong. If you ever end up with this, they need to be similar. They have to be the same. Okay? So the way that we're going to find the value that is going to be outside, like x, the way it is outside, for the other group, is by using this, what I'm circling here. So let me write it, I think, somewhere. Square root of 2x. I circle it. So I'm going to come back here. For now, forget about this. Forget about it. So I'm going to come here and get my first value. This one, which is 5x. I think let me do it here. Let me draw a box. 5x. Then I'll ask myself, remember that we need to end up with the same thing inside, right? Not what we end up with here. So I need this 5x to eventually look like square root of 2x. So I need to find that one value, which if I multiply 5x, it's going to give me square root of 2x. What is that value? So that value is going to be, so first of all, that value, first, when I multiply with 5x, it should cancel 5. And the only way it can cancel 5 is that it should be on the denominator. And it should give me square root of 2. And the only way I'm going to get square root of 2 is that square root of 2 should be on the numerator, 5 on the denominator. Because look, let me ask this. If I multiply 5, okay, let me tell you, multiply this one and tell me what you get. 5 times this, 5 and 5 will cancel, right? And I remain with square root of 2x. Okay, so I can only get what is here if I multiply this one by square root of 2 over 5. Now, how have I gotten this one? With the help of this. So once you just understand the logic here, then you will be just easily solving this. Now, I haven't arrived on the final answer. I mean, on the final value that is going to be outside. So now, to write the value that's going to be outside, I'm going to, for me to write my value, my final value that will be factored out, I'm going to swap this, their positions. 5 is going to be on the numerator, and this one is going to be on the denominator. So it's going to look like this. 5 over square root of 2. Now, why have I written like this? Because when you are factoring out, we are simply dividing throughout. So I'm simply telling you that I'm dividing this value and this value by 5 over 2. Let's do a demo. So let me say 5x. Let's start with the first value. 5x divided by 5 over 2. Okay. In case you didn't know, that's what it means when we factorize. We factor out. We're simply dividing that value throughout. So this is going to can also be written as times. It should be square root of 2. My bad. Times square root of 2 over 5. Okay, where 5 and 5 will cancel, and I remain with square root of 2x. And that is what I'm going to write here. Square root of 2x. And then I'll get this one. 5 square root of 2 divided by this value here. 5 over square root of 2. 5 square root of 2 times, which can also be written as square root of 2 over 5. 5 and 5 will cancel, right? Square root of 2 times 2 is going to be 2. So I'm going to say plus 2. Now if you see, with what we had here initially, they are finally having the same thing inside, right? Inside the parentheses. So this is how you approach it. So how do I find this value? I had to use this one. Then I asked myself, what number can I multiply this one so that I can get this thing here? I got this number. But again, I won't write this value because I'll be dividing. So I had to swap them. The one on the denominator went on the numerator. The one on the numerator came on the denominator. And that was my final value, which I had to write outside here. Now let me write them properly. So now, now that you know the whole thing, let me show you like this whole procedure here. You don't have to show them, okay? You don't really have to show them. I was showing you because I want to explain. Even this one, this procedure, don't show them. So now that I found out the value that's going to be outside, let me now write them properly. So this one, we already found it. It was x outside square root of 2 x plus 2 plus then this thing here, which is 5 over square root of 2 x plus 2. So now, in case you are doubting, like, Joseph, are you sure? Let me challenge you, especially on this part. Expand this, multiply this times this times this. 5 over square root of 2 times this. 5 over square root of 2 times square root of 2 x. This and this will cancel, right? We have 5x, which is the initial value. And 5 over square root of 2 times 2. It's going to times 2. It's going to give you, of course, 10 over square root of 2. Now I know you'll be like, but Joseph, this 10 over square root of 2 is not equivalent to this value. Let me show you. So we can rationalize this. Multiply by square root of 2 on the numerator, square root of 2 on the denominator. You're going to eventually end up with 10 over square root of 2. Now rationalize it. Guys, I've run out of space. Okay, let me do it here. So 10 over square root of 2 times square root of 2. So it's going to be 10 square root of 2 over this time. This will be 2. 2 into 10, it will be 5 square root of 2. So, which is also equivalent to what we have here. Okay. So I have proved it to you that I'm not wrong. So make sure that you understand this procedure. And then you're finally going to group them again. So I'll say this, I'll pair it with this one. So it will be x plus 5 over square root of 2. Then square root of 2x plus 2. Then we equate them to 0 now. So I'll get the first one, which is square root of 2x plus 2 equal to 0. I'll take this one on the other side, negative 2. So, okay, I've run out of space. Okay, let me continue on the next page. Alright, so say x. I was solving this one, right? Okay, let me get square root of 2 x plus 2 equal to 0. So I took this on the other side, right? Square root of 2 x is equal to negative 2. So I need to solve for x. Right? So what I'm going to do is that say divide by square root of 2 x is equal to negative 2. Okay, so now don't leave your answer like this, rationalize it. Whenever you see that you have a radical in the denominator, rationalize. Square root of 2 over square root of 2. So that's going to be negative 2 square root of 2 over 2. 2 into this one. X is going to be negative square root of 2. You can simplify your answer like this. So now I'll get this one and equate to 0. So x plus 5 over 2. Wait, have I forgotten something? No, should be, is this what I wrote? The one on the denominator is square root. It is square root. Yeah, square root of 2. So this one is square root. Alright, then we equate to 0. Then I'll say x is equal to negative 5 over square root of 2. Likewise, we rationalize. So it's going to be negative 5 square root of 2 over 2. Yeah, we can simplify our answers like this. So this is how you solve this type of equation. That guy who asked me in my DM, I'm sure you've watched this video. Like I didn't understand how I was getting that one. That one I was telling you that the one that's going to be outside, that's going to be factored out. The 5 over square root of 2. Okay, so question 2. Maybe if you haven't understood the previous one, you're going to understand this question. Okay, so I want you to pause the video. If you maybe think that you've understood, try to solve this one as well. Challenge yourself, like solve, then you compare with my solutions. Okay, so likewise, find the product. Product, we get it when you multiply. When I multiply this one times, no, this way. There should be 3 here. Just in that, what is this thing that's not making sense? Yeah, so there should be 3 here. Okay, so product, you get it when you multiply what is here times what is here. In this case, square root of 3 times 7 square root of 3. Okay, so this will be, this time this will just give us, so first of all, 7 times 1, which is in front there, it will be 7 times, this time this will give us 3. The reason why we are getting 3 is what I've taught in the video lessons. Go on Apple Academy app. You find lessons where I've taught the rules of multiplying radicals. If this is not making sense to you, it's not my fault. Don't comment that, no, sir, how come? No, you just go and research. If you don't want to subscribe to watch the videos on the Apple Academy app, you can maybe do a quick research on the multiplication of radicals. Okay, I don't want to teach from scratch because I've already done that hard work in my video lessons on the A Plus Academy app. Okay, so what is 7 times 3? It is 21. So the product is 21. The sum is 10. 21. So I need the factors now. I need what I can get. The two numbers which I can multiply to get 21. And if I add them up, I'll get 10. These will be our factors. These numbers is going to be 7, 3. So likewise, I'll say square root of 3, then plus one of my factors. Let me get 3. Just get any. And this method actually, you just it works like, even if you start with 7, you still eventually get the same values of x. Okay, so I'll say 3x plus another factor 7x, then plus this one here, which is plus 7 square root of 3. Now we start doing the madness now. Where most of you are getting confused, I know. I can feel it while I'm recording this video. I can feel it that some people will be confused on this part. But just rewatch the video, okay? Watch it over and over again, you'll understand. So let me see. What is in common here? Okay, actually, let me group them. Then we factorize each group. What is common in this group? So you only get what is in common in the first group, this first group. In this one, you don't do what we do here. So what is in common here is x. I factor out x, then I'll remain with 3, square root of 3, x plus 3. Now, don't do that madness here, okay? Don't go like, no, I'll factor out 7. I know that's what they taught you in grade 1, and you've mastered it. But now you're at the university, things have changed a little bit. This time they have put some radicals, okay? So we proceed. So I'll need to find the value that's going to be outside, that's going to be factored out, like the way we factored out x. Now I need that one which I'll factor out on the other group. Okay, now how am I going to find that value? I'll use this value here. So I'm having square root of 3x. So I need to find a number which I can multiply to this one for me to end up with square root of 3x. So let me draw a box here. I do the madness. So it's a 7 7x times. So I need to end up with square root of 3 on the numerator, so I'll say square root of 3, and I don't want to end up with a 7 anywhere. So for me to cancel this 7, I'll put 7 on the denominator, so that if I multiply 7 times this one, 7 and 7 will cancel, and I'll just remain with square root of 3x. So this is the value which I can multiply to this one for me to end up with this. Now I'm not going to write square root of 3 over 7. No. Instead, I'm going to swap them. The one on the numerator, which is 3, will come on the denominator. The one on the denominator, 7, will go on the numerator, which is 7. This one will come on the denominator. I know there is a mathematical way of explaining this. There is the reason why I'm doing this. But I don't want to confuse you more, because some of you are already confused. I'm trying to avoid that, okay? I can go deeper if I want. Now, I don't want to confuse you, and I don't want to make this video much longer. I know the video is already long. So it's about 30 minutes. Some of you are already tired, but me, I'm not tired. I can record this the whole day. I can record for 24 hours. Okay, so this is the value which I'm going to put outside. So I'm going to say plus 7 over square root of 3. Okay, so remember we are factoring out. When you are factoring out, it's like we are dividing this one throughout. So it's like we are saying 7x divided by 7 over 3 over square root of 3, which can also be written as 7x times square root of 3 over 7. This and this will cancel, right? So I have square root of 3x, which is what I'm going to write here. Trust me guys, this is the only way in which you can end up with things that are similar here and here. So I have 3x. Now let's come to this one. So if we're factoring out this one, it's more like we are saying 7 square root of 3 divided by 7 over square root of 3. So 7 square root of 3 times, we swap the positions, right? Square root of 3 over 7. 7 and 7 will cancel, right? And I remain with square root of 3 times square root of 3. So I'm eventually going to just end with 3. So I'll say plus 3. So if you compare this one, don't show this procedure. I was just showing you the logic, okay? Don't show this to your lecturer. He'll ask you, like, he'll write why. Why are you showing me this? That's Mr. Zakala. He'll ask you, why are you showing me this? Do you think I don't know this? Okay, so now him will just write why. Why are you showing me this? Okay, I'm just kidding, but let me just say it is unnecessary, okay, to show this to your lecturer, because the lecturer already know the logic. I know it will show your work, but some things, guys, no. Okay, you don't have to show everything. So now I'll pair them. Have you seen we finally ended up with similar stuffs? So if you are supposed to, if you are to be stubborn enough that no, I'll just factor out 7 here, you can get this wrong. Okay. So let's now pair them up. So I'll pair this with that one there. So I'm going to have x plus 7 over square root of 3. Okay. Then these things that are in common, which is square root of 3, x plus 3. Then we start equating each one to 0 and so for x. So we have x plus 7 over square root of 3. So x is equal to negative 7 over square root of 3. Rationalize. Guys, let me give you a tip. Whenever you see that you are having a radical on the denominator, even if they haven't told you, rationalize it. Lecturers like seeing you doing this. Some won't even give you the full marks. They will just put y. That's Mr. Takala. Wait, I'm sure if you're watching this video right now, you haven't written your test 1. Wait to write your test 1, especially if your lecturer is Mr. Takala. He like doing this to my comments. Why? How? Especially you people who have the habit of, you, instead of showing your work, maybe you just write this part and you also write the final answers. You won't mark. You just write how, and that's how you get a 0. Okay, so make sure that we show the important steps. Okay, So we have negative 7 square root of 3 over square root of 3 times square root of 3 is going to give you 3. So the answer is negative 7 square root of 3 over 3 when we rationalize. So now let's get this one and equate to 0. So we have square root of 3x is equal to negative 3 over square root of 3 over square root of 3. And I repeat, guys, that tip that I gave you is very important. If possible, write it somewhere, okay? You know, it doesn't make sense whereby you know how to solve something, but just because you didn't finish it unknowingly, then you fail to get the full marks. I've seen students failing to get 100% because they just failed to rationalize the denominator. They deduct a half mark or a 1 mark. So it's going to be, I'll rationalize this one, square root of 3, square root of 3. So it will be negative 3 square root of 3 over this and this, it will be 3. So the final answer is negative 3 square root of 3 over 3. This is 3, guys. I'm not in a good position like where I'm seated, so I'm unable to write some straight things forward. Yeah, but so when you cancel 3 into 3, it is going to be negative square root of 3. Alright, so we have this question. Now this one will be your homework. I want you to give me the solution because I've already solved enough, guys. Question 1 and 2, I'm sure by now you understand. I just want to help you on maybe finding the factors to you who don't know the radicals, okay? So the product is what you get when you multiply this and this. So this times this. So you multiply 3 times 10, that will be 30, right? Times this, 5. 30 times 5 will give you 150. And then the sum is simply what is here, which is 25. So I need those two numbers whereby if I add them up, they should give me 25. Then if I multiply them, they give me 150. And these two numbers are 15 and 10. Okay. So now start doing the madness now. Now start brainstorming. Finish this one. Okay. Now I've helped you with the factors. I want you to finish them up. Then comment in the comment section there. Put a comment of what you get. Okay, so let's move on. Alright guys, so the other question, C, is saying solve each of the following using quadratic formula. So listen, so far we've looked at 3 methods that we can use to solve a quadratic equation. The first one is the complete the square method, the factorization method, and the last one is this one, quadratic formula. So this one, I don't think I'll solve any equation because you already know this. Like, okay, I don't want to make the video unnecessarily long. Like the previous video, it was just so long, 2 hours, whereby I was solving things that you already know. Yeah, so this one, the quadratic formula is that one which we call the bus formula, where you say x is equal to negative b plus or minus b squared minus 4ac over 2a. So just start plugging in. What is a? And a is what is the coefficient of this one, which have x power 2. B, the coefficient for this one. C is what is found here. Just plug in and solve. Okay, there's nothing hard here. Okay, so this one, so you're going to try. And let me, I think I'll just give you some, the answers. And in case maybe you just want a solved document so that you can just easily be comparing. You can be comparing easily. You can contact me so that you can have the L Plus Academy app. The solved solutions and written ones are there. So the first question, when you solve, you should get x should give you negative 2 over 10 minus 4i over 10. This I is a complex number. You get this when you have a negative under a square root. Okay. And this one, negative 1 over 5 minus 2i over 5. Okay, let me just keep this question because these things are easy, you know them. And if you want the full solutions, like if you want, you can check the solved document so that you can just compare when you solve. Alright, so you're just going to skip C. I'll call 2. Now D, the graphing. So here what I'll do is that I'll just graph one question because the concept is the same. The way we can graph this one and this one and this one, it is the same. Okay, so I'll just graph one, then you are going to try out these others. Right? Yeah, then I'll come to this one also. Okay, so I'm going to solve the last question, then you are going to try out the first one because the last question is a little bit advanced since it is having a negative in front. Okay, so let's solve let's graph this one because tutorial sheet 5 is having a lot of questions, so I want to solve more important tough questions. Okay, that's why I'm rushing on these simple things. There are some questions whereby if you can solve this, you can solve any question. If you can solve this, you can solve any question. That's why I'm quickly skipping them. But if you want the solutions, contact me. And they are already there on the app. If you just want to solve each and every question, solutions are already there on the app. Okay, so we need to graph this one. So for us to graph this one, there are some things that we need to know. We need to know our turning point, which we summarize as the TP. Or let me say the coordinates of the turning point. Okay, we need to know the y-intercept, and also the x-intercept. Now listen, this one is not necessarily that you have to find it, unless in the question they have stated that show the x-intercept. Okay, I repeat, don't force yourself, but I'll find for this question. Okay, but these two are mandatory. These two, you need to find them. So the way that we find the TP is that we need to use the completing the square methods. And I think I've taught two methods. There's a method that I've taught on the app, and there's a YouTube video, Mr. Sakala's completing the square method. The method that Mr. Sakala uses. Check on this YouTube channel, on the YouTube channel here. You'll find the video titled Mr. Sakala's method for completing the square method. Yeah, so there are two methods that you can use, like the way we just handle things. Okay, so I'll use one of those two. Okay, so let me just write the expression again. We apply completing the square method. Alright, so in a case whereby you have something in front of x power 2, you're going to factor it out. So first of all, let me group. So I'm going to group these two, which is the one having x power 2 and the one having x. I think this is Mr. Sakala's method. Yeah, this is Mr. Sakala's method, I think. Yeah, so I'm going to factor out a negative. So I have x power 2. Remember, if I say factor out a negative, we're dividing this negative throughout. So here I'll have negative 7x. Then I have minus 12. Okay, so I'll get what is here, negative 7 multiplied by 1 over 2. So it's going to be a negative 7 over 2. Alright, so I'm going to say negative x power 2 minus 7x. By this time, I'll say plus this one, negative 7 over 2. I raise it to the power of 2 minus itself again, minus negative 7 over 2 power 2. We cross the bracket, then I'll say minus 12. So I'm going to group them. Since this and this are raised to the power of 2, I'm going to say put them under the same parentheses. You can use any procedure for completing the square method that you are used to, okay? I know there are many procedures, but this is among the procedure. But still, we end up with the same thing. Don't stress. So x minus 7 over 2 power 2. And what have I remained with? I've remained with. So these, I'm done with them. I've just remained with negative 7 over. And if you don't understand what I'm doing here, go and watch the video on the A+ Academy app. I'm just applying the knowledge of the video. Applying the knowledge that is in the videos that I've uploaded on the A+ Academy app. There are some students who have subscribed to the app, but they don't watch the videos. I don't know why. So right now they are surprised like, did you teach this? I've already taught these things. Okay, so just simplify this part. Or let me just expand. So I'll say this times this is going to give me negative x minus 7 over 2. This times this is going to give me plus negative 7 over 2 power 2 minus 12. Right? So let's simplify this. And 7 over 2 plus this will give us 49 over 4 minus 12. So simplify this, like leave it as a single fraction. So find the common denominator, which is 4. 4 into 4, that is going to give 49. This into this, it is 4, right? 4 times negative 12 is going to be negative 48. So when you simplify, you're eventually going to end up with x minus. So right now, this whole procedure, I'm trying to find the turning point. I know there is a short method of finding the turning point, but I recommend you use completing the square method. I know there's a formula whereby to find the x coordinate you use b over, negative b, or you say negative b over 2a, right? To find the x coordinate. Now, I won't even show you those formulas, because lecturers like it when you show it like this. Okay, so minus 7 over 2 power 2 plus, so when you simplify this, you get 1 over 4. So remember, our main goal is to find the coordinates of the turning point. So since they are coordinates, there should be the x coordinate and the y coordinate. The way that you find the x coordinate is that get what is inside the parentheses, which is x minus 7 equated to 0, x minus 7 over 2 equated to 0, and take this on the other side. It's going to be x is equal to 7 over 2. And I know that in this video I'm rushing, but when I'm teaching, in the videos that I teach, I take my time to explain. I'm rushing because there are many questions to solve, so I'm trying to be fast, and I'm finding myself stammering when I don't even stammer, when literally I'm just trying to rush to just at least move a little bit fast. Okay, so I've just gotten this equated to 0, and I'm getting 7 over 2. So the coordinates of the turning point, the x coordinate is going to be 7 over 2, and the y coordinate is what is here, 1 over 4. 1 over 4. Let me write it here. So TP is equal to 7 over 2, 1 over 4. Okay, so now let's find the y-intercept. So I want you to take note of this. We'll need these details to graph. Okay, so we have found the turning point, right? So now for me to find the y-intercept, first let me write the equation that we have been given, minus 12, right? So for me to find the y-intercept, I'm going to substitute x with 0. So it's going to be y is equal to, why there's x, I'll put 0, 7, 0. Then I'll say y is equal to, this will give me 0, this will give me 0, minus 12. This is how you find the y-intercept. Just get the initial equation, y is x, put 0 there. Okay? Alright, does it make sense to you? Yeah, so y is equal to negative 12. So this is my y-intercept. Y-intercept is where the graph is going to pass in the y-axis. That's why it is going to cross from. Now, to find the x-intercept, you put 0. So we found the y-intercept. Take note of this. You put 0 here, negative x. Then solve for x, meaning that now use either the quadratic method, the quadratic formula or factorization formula. or they complete the square method, you still get the same answers. So if they tell you find the x-intercept, they will just want you to solve for x, which is something that I've taught. Okay, so I won't show this part, guys, and usually they don't even ask about this, but be careful in the question. If they have said make sure that you show all the intercept, meaning that you have to graph, you have to solve for x before you graph. So my details of interest is the turning point and the y-intercept. Okay, so I'm going to do this. Right. So so what am I going to do? So what do we do now? Now we graph, right? Look, the turning point and the y-intercept are enough for you to start graphing. So first of all, you need to graph your turning point. Turning point, where is it? This one. So mean that this is the x-axis, the y-axis. This should be in the x-axis, this is in the y-axis. So in the x-axis, I'm having 7 over 2. In the y-axis, I'm having 1 over 4. So the turning point is simply a point where a graph is going to turn from. In the other terminology that I like using is the vertex. They will tell you find the vertex. Find the vertex. So that where it turns from, okay, that point. So we are just going to find that point, which is this point right here. Okay. And me, I'm using my free hand, guys, but hope you forgive me if I draw some bent lines. And show now the y-intercept. Negative 12 is going to be here. So now your job is to just draw a graph that is going to cross. Okay, let me do this. So that graph need to pass at negative 12. And then turn from something like this. Make sure that you draw a nice graph. You'll be in an exam with a pencil. Make sure that you take your time. Draw a nice graph, okay? A very nice graph. Yeah. So, but whatever you are going to draw, make sure that it has crossed the negative 12. It has bounced here. It has turned from the turning point. You should even label this as TP. Then when it turns, it comes down like this. Now, suppose maybe they said show the x-intercepts. So when you solve for x, this one, those values that you're going to get, one of the values is going to be here, the other value is going to be here. Since this is a quadratic equation, you are expecting to get two answers, two values of x. So the first value is going to be here, the other value is here. Okay? The x-intercept is simply the value in the x, where the graph is going to cross from, like where it's going to pass when it crosses the x-intercept, the x-axis. So this is how you graph. Plus F. This is where you access all the full videos. So what you just do is come here on videos and then click on term 1, term 2 or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions. If you haven't understood everything that we've learned so far, or that we're going to cover in the video, okay, so all these topics, okay, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are. Then you catch up at the end of the day. And we have a lot of students who are watching these videos and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. you're going to find videos about it. Okay, but it's not only math, even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just use CH110. You find the videos here. Okay, if it's introduction to chemistry, you'll find the videos. So all these topics have been taught. Alright, so it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A Plus Academy app and start learning and practicing with our solved materials. Alright, so let's solve this question. This is question 2b. So they're saying that find the value of k for which this line given by this equation, this is the equation of a linear line. So this line, having this equation, is tangent to the curve of this equation. So here basically it's like there is, let me sketch this equation for you. Okay, but before I do that, let me just read that again. So they're saying that find the value of k for which this line is tangent to the curve. So here is how we can sketch this equation for us to easily solve it. Right, so they are saying that there was a curve, right, and then there is also a line which is tangent to this curve. So if a line is tangent to the curve, it means that it is touching, there is a line. Okay, let me, I think, withdraw. This is not how we should pass. It means that this is a curve, right, and there is a line that is touching this curve at only one point. I've cancelled this one because I wouldn't have showed a single point properly here. Okay, so there is some sort of a curve, and there is also a line like this. Okay, so there is a line which is tangent. So this line is tangent to the curve because it is touching this curve at one point. So we can label this straight line as x plus y is equal to k, and the curve, the equation of the curve is x minus y plus 2 is equal to 0. Alright, so now listen, this straight line and the curve, they are meeting, they have met somewhere. Okay, so since they have met somewhere, for us to find, we need to find the point at least where they meet, or an equation that will lead us to find where they meet here at this point. Remember, these two lines have met somewhere. So what I will do is that I'm going to solve these two simultaneously, these two equations. I'll make a certain value in this one is subject to the formula. Then I solve them simultaneously. So let's begin with this one. So let's get the equation of the straight line. So I'll make y the subject. I'll take x on the other side. I'll call this my first equation. Okay, and then I'll get the equation of the curve, which is x minus plus 2 is equal to 0. So I need to make y the subject even in this one. Okay, and the way that I'm going to do that is, let me expand this one. I'll say x power 2, right, minus yx plus 2 is equal to 0, right? And then I'll make y the subject. So let me first I need to make y the subject. So let me take this yx on the other side. Then I'll say over x. So y is equal to x power 2 plus 2 over x. Okay, so I've just made y the subject in the equation of the curve and the equation of the straight line. So let me also call this second equation. Okay, so now we have two equations which are easy to use. So now, if you want, you can get this equation and this equation, then you equate them to each other and you start solving, because these two are meeting at a certain point. Or you can just solve them simultaneously. You can use any approach. So I've said I have this equation, y is equal to k minus x over y is equal to just 2, right, over x. Okay, so we have these two equations. So what you can do is that you can get this whole thing here and substitute what is y. So we are going to end up with an equation looking like this, equal to x minus, get the second equation, where is y, put what is here, okay, x minus, x power 2 plus 2 over x. So let's try to simplify this. Let's see how we can simplify it. Right, so let's cross multiply. Cross multiply is going to be x power 2 plus 2. Right, so this time this it will be xk, this time this it will be equal to. Okay, so let's just take what we're having here, we take it on the other side. So we have xk minus 2 minus x power 2 and then minus 2, right? So we can simplify this. Is going to be negative 2 when we sum this and this, negative 2x power 2 plus xk minus 2. Right, so we have this some sort of equation, right? And let me just try to write. Okay, yeah, they are already written properly. So now we need to find the value of k. We need to find the value of k. Now this, for you to solve this question, you need to understand the discriminant, the concept of discriminant of the roots. And if you don't understand discriminant, make sure you check the videos on our app, on A+ Academy app. The video lessons are there. So go on A+ Academy app. I'll put the link in the description where the app is. It's there on Play Store. And then go under the videos for functions. You will see a video which is having discriminants of the roots. So that's where I have taught the concepts that I'm about to apply. Okay, so I'm about to apply concepts which I won't teach you from scratch because it will take time. I've already taught in the videos which are on the A+ Academy. So now here are the concept. So now remember that the question they're saying that there is a curve, right, which is having a line which is tangent to it. Now this line, if you observe, it is only passing at one point. Okay, so in this situation we can say that they are equal. Let me just say they are same or equal real roots, because at one point here there is just like one value here, one value of x and one value of y. Okay, so we can use this one, which is b power 2 is equal to 4ac. And I'm sure if you've watched the video, you know when they say tangent, we usually use this one. We always use this one, right? Because they are equal or same roots. Because they are we are just going to end up with one type of a root, since it's just at one point. Okay, so let's now plug in this equation to solve for k. So where is B? B is this one, K, and A is -2, C is -2 as well. So it's going to be K power 2 is equal to 4, -2, -2. So it's going to be K power 2 is equal to, if you multiply 4 times 2, that will be 8. 8 times 2, 16, right? So be 16. So for us to solve for K, we are going to make K the subject of the formula, which is going to be achieved by introducing 1 over 2. Okay, let me not use 1 over 2. We are going to raise both sides. We are going to introduce square root to both sides. And this is going to cancel with this one, right? Here are just going to remain with K. Square root of, and when we introduce square root, meaning that we end up having plus or minus. So it's going to be plus or minus. Square root of 16, that is 4, right? Square root of 16 is 4. So the possible values of K are positive 4 or negative 4. This is how you solve. So this is the concept. This concept is coming from discriminant of roots. And the whole topic has been taught with a lot of examples. I think even this type of example I've solved it in the videos. Yeah, so make sure that you download the A+ Academy app. Alright, so we have now, let's go to question C. So they're saying that for what values of W will the function, this function, first one they're saying, cut the axis twice, touch the axis, have no x intercepts. Okay, so so they're saying for what values of W. So basically here they want you to find the value of W in this equation in each of the these conditions. In the first condition, second condition, and third. So you're going to find W using the same equation when it cuts the axis twice, it touches the axis, and it has no x-intercept. And we only do this by using the concept of discriminants. Okay, I'm sure if you've watched my video lessons on the A+ Academy app, you know which appropriate equation to apply in this situation. Okay, now this video is to apply the concept. It is to solve, not to teach. So let me just directly go and solve, but I'll be trying to explain while solving. Alright, so the first equation, the first condition is when it cuts the axis twice. So look, they have given you this equation of a quadratic function, right? So now let's try to sketch it. They're saying when this cuts the axis twice. So now listen. Let's say we have this Cartesian plane. So for it to cut the axis twice, it means that it is looking something like this. It has passed here where it had to cut the axis once. It had to come back and cut even this axis for the second time, cutting it twice. So if you find the roots of this one, you find that it will end up having two distinct roots, where the first root will be here and the other root will be here. Okay, will be for this point and the other one for the other point. So in this situation, we are going to use the discriminant equation, which is used whenever you have two distinct real roots. This is how you analyze these types of questions. Okay, I'm sure if you've seen those who have access to the app, in the solved tutorial sheet, I was even sketching before I solve. That's how I solve the tutorial sheets. I don't just go direct and just write the work. I have to give you a picture. Okay, so the right equation to use is b power 2 greater than 4ac. Right? So where a is equal to 1 and b is equal to 6, c is equal to w. Right? So let's plug in this equation. So where this b, I'm going to put 6 power 2 greater than 4. Where this a, I'll put 1. Where this c, I'll put w. So I have 6 power 2. So now what is 6 power 2? It is 36, which is greater than 4 times w, to be 4w, right? Then over, I need to make 4 the subject. So it's going to be, how many times did it go there? So 4 into 36, it is 9. So the value for w, they're saying that 9 is greater than w. So this means that if 9 is greater than w, it means that w is less than 9. Have you seen? As simple as this. So we can even conclude this in intervals by writing, since w is less than 9 and there's no equal sign here, if we were to write this in interval notation, the value of w, they are going to be starting from 9, which won't be part of the set, going to the negative infinity. So it's going to be written like this. But I won't use the square bracket, I'll use this parenthesis. So it's telling us that 9 is not part of the set. Okay, so let's proceed and solve question 2. Right. So the second situation is where they have said where it touches the axis. Now I want you to understand the difference between the word touch and cut. So the previous question they said it cut. It when it cut the axis, it appears something like this. Remember, you say now put to la for it to pass by, it had to cut to cross. Okay, this is how it looks like when it does cut. When it cuts the x-axis. Now, if it touches, it doesn't mean that it has crossed, meaning that it doesn't cross anywhere like the way it is crossing on this point and this point. No. So it means that it possibly just maybe did this. This is how maybe the graph appeared like, or maybe like this. It just touched, but it didn't cross. Alright. So if you are somebody who has watched my videos where I taught discriminant, I'm sure you know that this means that this is going to have equal real roots or same equal real roots, meaning that the appropriate equation, since it is just passing at one point, the appropriate equation to use is going to be b squared is equal to 4ac, right? So now remember the equation given in the question, it is x power 2 plus 6x plus w, right? And a is 1, b is 6, c is w. So while this b, let's substitute 6 for 1 and w, right? So what is 6 power 2? So 6 power 2 is 36. 4 times w, that is 4w over, so over this one, don't even stress, okay? So w will be just 9. Y is equal to 9. Right, so let's look at the third condition given. Right, so the third condition, they're saying it have no x-intercept. I'm sure this one is self-explanatory unless you're somebody who hasn't watched my lessons on the A+ Academy app. Only you will be confused. Okay, so what does it mean when you draw a graph that does not have x-intercept? X-intercepts. First of all, it means that its roots. Okay, let me draw it for you. So this graph, it won't cross anywhere like in the x-axis. It won't touch. Look, it won't touch anywhere, and it won't even cross anywhere. It will be just hanging above or below the x-intercept, something like this. It will look anything like this. It won't make any contact with the x-axis. if this happens, whenever you draw a graph and it comes out like this, just know that if you try to solve the quadratic equation for that one, you will get complex numbers. Yes, that's the reality. So it means that its roots are not real roots. Instead, they are complex numbers. That's why it is not. Because look, you can't plot the complex numbers in this type of axis. Like you can't put it on in this axis. No. Okay. Because these just have the real numbers, not the imaginary. There are no imaginary parts here. That's why it can't fit in the x-axis. So I'm pretty sure by now you know the right equation to use, which is b power 2 less than 4ac, where b is equal to, if you remember the equation, b will be equal to 1, my bad, a will be equal to 1, b will be equal to 6, and c will be equal to w, right? So where this b, I'll put 6, 4, a, and where there is c, I'll put w there. So 6 power 2, that is 36, right? 4 times w, that will be 4w over 4, and w will be, my bad, yeah, so it's going to be 9 less than w. This is w, guys. Okay, let me just rewrite it. Yeah, so we are saying that 9 is less than w. Now, if 9 is less than w, it means that w is greater than 9, which I can also write. This means that w is greater than 9. So I can write the values as, so if it is greater than 9 and there's no equality sign, 9, we start from 9. If we write it in intervals, it's going to be like this. Makes sense, right? So all you need to understand are the discriminants and how you can apply them in the questions. So let's go 3. So they're saying that the equation, this has real roots. What is the range of the values of p? So like this one, they have told you that it has real roots. Now,
Hi everyone, I'm Namchenja Naomi, a former A Plus Academy student, and I want to share how A Plus Academy completely changed my learning journey. Before joining, studying felt so overwhelming, but A Plus Academy made everything clear, simple, and easy to follow. What makes A Plus Academy to stand out is how effective the teaching style is. To start with, it uses Telegram and also A Plus Academy app, which you can download on Play Store. On these platforms, there are videos, well-explained videos, solved story sheets, solved exam papers, solved test papers, and also pamphlets for BI 110, which involves answered test papers. There are 4 courses that are taught on these platforms, unlike other tutors who only offer 3 courses. So the courses that are taught are PH 110, MA 110, CH 110, and also BI 110. So it was all because of A Plus Academy's help that I managed to get A pluses in all the 4 courses that are offered. I'm pretty sure that if it was offering CS 110, LA 111, I could have gotten A pluses too. So you can also take a look at my results on the screen that I'm genuinely proud of, and I highly recommend all of you doing non-quota to join the only affordable and best tutorial in school. Thank you.
alright, so let's go to question 3. So question 3 is saying the equation, this equation here, as the real root, what is the range of the value of p? So they want you to find the value of p. Okay, so now you need to use the equations under discriminants of the roots. So let's see how we are going to analyze this. So I want you to take note of a certain state. So they have only said that it has real roots. That's it. Let me even underline it. Real roots. Okay, so let me write the equation first. So we have x power 2 minus p plus 2 x plus p power 2 plus 3 p is equal to 3, right? So now they have only said that it has real roots. Now, the roots are real, meaning that they are not complex, right? Like they are not over complex numbers. And then the other thing that we don't know is that we don't know whether these roots are equal to each other or they are distinct. Remember, the real roots can either be equal, the same, or they can be different or distinct. When I say distinct, the word distinct means different. So in this question, they have only said they are real roots. So these can, we don't know whether they are equal or they are different. Okay. So we are going to assume both cases. Because look, if they are okay, let me start with distinct. Okay. So if the roots are distinct, it means that we are going to use this expression. If they are different, the real roots are different. We're going to say b power 2 is greater than 4ac, right? And if they are equal, we are going to introduce the equality sign. So whenever they just tell you that the roots are real roots, they haven't said whether they are equal, the same, or distinct, you always introduce this equal sign. So it's going to be equal or greater than. Okay. So we are going to use this one to solve for p. So where is b? So let's analyze this one. So if you look at this equation given, okay, this is a quadratic equation. And if you remember, a quadratic equation is written in the format of ax power 2 plus bx plus c. So what is our a? Our a is whatever coming in front of x power 2, right? So a is just going to be 1 because it's like this 1. And b is whatever coming in front of x, this. So b is going to be equal to negative p plus 2 because it's this is the only thing coming in front of x. Now, what is c? So c, it is quite tricky here. You need to be careful. So obviously now the equation is oriented. A quadratic equation should be like this, and it should be equal to 0 whenever you write it in this format. So there's this 3 that's on the other side. We need to bring it back to this side. Let me just rewrite the equation I show you. Plus 2 x plus p power 2 plus 3p. This 3, I'll take it on this side because I just need to have 0 on the other side. So I'll say minus 3. Then I'll say equal to 0. So we've noticed that this is our b, right? So this means that this whole thing here, it is presenting c. So I'll just write here. So c is equal to p power 2 plus 3 power 2 minus 3. So now your job is to substitute in this equation where there's a, b, and c. So where there's b, I'll put so when you expand this, it's going to be, okay, let me just put it outside the way it is. Negative outside, p plus 2. Since b is raised to the power of 2, I'll raise this to the power of 2. Greater than or equal to 4. Where there's a, I'll put 1. Where there's c, I'll put p power 2 plus 3p minus 3. So we are raising this to a power of 2. So since it's a negative, these two will cancel this negative, and we are going to remain with p plus 2. Remember, whenever you raise anything to an even exponent or to a power of 2, the negative always gets cancelled. Okay, so we have 4 p power 2 plus 3p minus 3. Right? And don't forget power 2. Power 2 has only cancelled this negative, okay, but it's still here. So now let's expand this side. So I'll show you, I'll use the shortcut of expanding, which is I raise this to the power of 2, p power 2, plus this to the power of 2 is 4, right? Then plus 2 times p, 2p, 2p times 2, that is 4p, greater than or equal to 4 times p power 2 is 4 power 2 plus 4 times 3p, it is going to be 12p. 4 times this is going to be negative 12. Right? Right. So right now your job is to get everything that is on this side and take it on the other side. Okay, so I'll write p power 2 plus 4p plus 4. This, when it comes on this side, it will be negative 4p power 2. This, when it comes on the other side, is going to be negative 12p. This, when it comes on the other side, is going to be plus 12. The negative, this one, negative changes. Okay, then we can now equate to 0. Let's try to add the like terms, subtract the like terms. Let's simplify this. So the like term, this and this, they'll give me negative 3p power 2. This plus this, they're going to give me negative 12p. And 4 plus 12, that's going to give me 16. Right? And my bad. So I should not use equal sign here. I should maintain the greater than or equal to sign. Yeah. So now for you to solve for p, you need to solve this quadratic equation. And the easiest one to use in this situation is what some of you call the bus formula, but in mathematics we call it, my bad, you might forget. Okay, let me just start again. This b is equal to negative b plus or minus b power 2 minus 4ac over 2a. Okay, so in mathematics we call this the quadratic formula. Whoever told you this is a bus formula lied to you. So let's start. So where there's b, so now remember our a is negative. Our a is negative 3. Wait. Yeah, our a is negative 3. Our b is negative 8. And our c is 16. So let's substitute in this formula. So where there's b, I'll put negative 8. Okay, let me do this. Negative 8. We say plus or minus. So where there's b, I'll put negative 8 as well. Power 2 minus 4. Where there's a, I'll put, what is a? A is negative 3, right? Negative 3. And what is our c? Our c is 16. 2a. Why there's a, I'll put negative 3. So just solve this. And now listen carefully. So right now, if here there was just an equal sign, the moment you solve for p, whatever you get can be your final answer. Now, what you are having right now is, this is what we call a quadratic inequality, because it is involving these from signs of greater than, less than. So you go beyond that. So right now, I'm not solving for the value of p. No, I'm solving for the critical values of p, which will help me to find the possible solutions of p. We will be required to draw the sign table afterwards. Okay. Right. So p is equal to, this time this is going to be 8 plus, this is going to be negative 8 power 2, that will be 64. This times this times this, it's going to give you plus 192. So p is equal to, so we have 8 plus or minus, this is going to give us 256 over 2 over 2a. So this time this will be, I forgot to write it on this step. So this time this is going to be negative 6. What's the square root of 256? So p is equal to 8 plus or minus, okay, it is 16, negative 6. So let me just write that one properly. Okay, so p is equal to can be 8 plus 16 over negative 6, or p is equal to 8 minus 16 over negative 6. And when you sum this and this will give you 24, right? 16 into 24, it's going to give us negative 4, right? And this one is just going to give us p is equal to negative 8 over negative 6. We can reduce this 2 into 8, 2 into 6. It's going to be 4a and 3 here. These are 3. So right now we have just found the roots. So we need to find now the original possible values. So these are just like the critical points. So we can take this, we need to find the factors. Since we would need to draw a sign table, let me show my factors here. So to find the factor, look, here you found that p is equal to negative 4. To find the factor, you can just take this on the other side, which is going to be p, the sign will change, right, plus 4. It will be even equal to 0. So you found the first factor. To find the other factor, you're going to say p is equal to 4 over 3. You can take this on the other side, and p is going to be minus 4 over 3. Right? And then, so you have two factors, right? And you have two critical points. So you can now easily draw the sign table. I'm using my free hand, so maybe it might not be perfect. So we draw the sign table. So here we put the factors, which are this and this. So it will be p plus 4. And here let me put p minus 4 over 3. And then here we do this. So these are the critical points that I'm going to put here and here. So here I have negative 4, here I have 4 over 3. So I mean that between this and this, here they can be 0, right? Here we can put maybe negative 5. Here maybe we can put a big number like 10. So if I put this where this p, am I going to get negative or positive? To be a negative, right? If I put here, it's going to be a negative. So the overall here is positive. And then 0, if I put 0 where this p, it's going to give me positive, right? If I put 0 where this p, in this one, it will give me a negative. So here I have negative. And if I put 10 where this p, here is going to give me positive, right? If I get 10 and put it where this p, it's going to give me a positive as well. So we have a positive here. Now listen, since in the question they give us this sign greater than or equal to, it means that we are interested in the positive regions. So we have two positive regions. So only in these positive regions, that's why you find the true values of p, or the range of values of p, which is what they are looking for. So I'm just going to say, so we start describing from negative, and since there's an equal sign here, this and this will be part of the solutions. So from negative 4 to the negative infinity. So going to the negative infinity, starting from negative 4, which is going to be part of the set. And then from 1 over 4 over 3, from 4 over 3, which is going to be part of the set, going to the positive infinity, like this. Okay, so this is the range of values of p. I hope it makes sense. So just go and find the values of t if the equation this can never have equal roots. Simple, right? I'm sure you know the right equation to use. Alright, so they have said that they want you to find the value of t. Wait. Let me just no, the question should be find the value of a. We are going to find the value of t on the next question. For this one, we just need to find the value of a. Yeah, so they want you to find the value of a if the equation, this equation, it can never be equal, I mean, it can never have equal roots. So I told you that there are two possibilities, right? If we have real roots, it can either be that these two real roots are equal. When they are equal, we use this one for AC, or it's either they are equal or they are distinct. Okay, so if they are distinct, we use this equation for AC. So now they have already told us that it can never have equal roots. So this one is already disqualified. So the only qualified one is this one. So it's going to be B greater than 4AC, where A is equal to A power 2, B is equal to A, C is equal to 1, based on this expression given, the equation. So now, where this, I'm going to substitute, there should be power 2. So where this B power 2, I'm putting A power 2 greater than 4. Where this A, I'll put A power 2. C, where this C, I'll put 1. So this time, this is going to be A power 4 greater than, it's going to be 4A power 2. Right. So the way that we're going to solve this is that I'll say A power 4 minus 4A power 2 greater than 0. So I can factor out A power 2, and here I remain with A power 2 minus 4, 0. So right now, let's just solve this part, like we equate each to 0. So A power 2 is equal to 0. So the first possible value of A is 0. And then we have A power 2 minus 4. So this is a difference of 2 squares, right? I mean, negative 2. So we have A plus 2 or A minus 2. So the possible values of A is going to be A minus negative 2 or A is equal to plus 2. Alright, so we're going to draw a sign table. These are the critical points. And let's try to find the factors that we're going to use. So the first factor will be just A for this one. The other factor will be, I'll take these two factors. So we have A plus 2 and A minus 2. Now when you look at this carefully, this should give us two answers, right? Because it's a quadratic, like it's power 2. So I'm just going to put power 2 to this one. Or if you want, you can write this one twice. So you have 4 factors. Okay, let me do this. They are like repeating factors. So we have A plus 2 and A minus 2. One, two. So put here. I think even here. So okay, let's start. So we have. Okay, I think this. Okay, let me put the first one 0. oh no, the first one should be negative 2, then 0, then 2. So this one, let me just get rid of it. So if I put this one, I mean, let's assume here there's negative 3, here there's negative 1, here's 1, there's 3. If I put negative, it would be negative, 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 negative. Yeah, so positive, positive, so positive. If I put negative 1 here, negative, negative, positive, negative, so positive, negative 1. So put to be positive, positive. So put it there to be positive, there to be negative. So put negative. If you put 3 there, it will be positive, 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 and positive. So it's strange. Let me just check. So we're interested in the positive regions since there's a greater than sign here. Yeah, so the possible values of A are those values which are starting from negative 2. Since there's no equality here, negative 2 should not be part of the set. So from negative 2 going to the negative infinity, united with from positive 2 going to the positive infinity. Okay, so and actually you can try to prove this, like use this one. Why this A? Like try to put any value between this and this, between negative 2 to positive 2, including negative 2 and positive 2. You will see that it will give you something that won't be greater than 0. But if you get a value starting from negative 2 going this direction, and okay, let me not say starting from, like after negative 2 and after positive 2 going these directions. For example, if I put 3 here and 3 here, you will see that it will give you something that is greater than 0. So this is actually true, in case maybe you are doubting. This is true. Okay, so and the purpose of drawing this line table is to just determine the true value which satisfies this condition here. So we proceed. So see, they are saying find the values of t if the equation, this equation, has equal roots. So this time they have told you that if the equation has equal roots, all right. So they have said that find the value of t of this equation, provided that it has equal roots. So if it has equal roots, we use this equation for a c. All right. So where a is 1, b is what is coming in front of x, that is t minus 2, and c is what is here, which is 10 minus t. Okay, so where is b? I'll say t minus 2 power 2 is equal to 4a. Where is a? I'll put 1, and then c, where is c? I'll put 10 minus t. So you can expand this one. There's an equal sign here actually, so you can expand this side, and it's going to be t power 2. This is the shortcut I used to expand. Then this power 2 is going to be plus 4, then 2 times t, that is 2t, then 2t times negative 2, that will be negative 4t. I'm sure you've learned something today. Then we say equal to 410 minus t. Let's let me just try to double check my work. 4ac. Yeah. Okay, so let's just expand that side. So you have t power 2 plus okay, let me say minus 4t plus 4 is equal to 4 times 10, that's going to be 40, right? As 4 times negative t, that's going to be negative 4t. Then t power 2 4t plus 4. I'll take this on the other side, it's going to be negative 40. This on the other side is going to be plus 40. 4 and t, not 40 as in 40 a number, no. 4t. This is t. So let's try to add the like terms in 10. So I'll start t power 2. This will cancel with this because they are the same having different signs. And then this and this basically is like you're saying 4 plus negative 40, which is going to give you negative 36 equal to 0. So I can simply take this on the other side, right? Raise both sides to the square root. So t is going to be, and when I introduce the square root, this one becomes plus or minus. So square root of 36, it is 6. So t is equal to either positive 6 or negative 6. Alright, so question 5, they're saying, so maybe I've skipped some questions, but if you want to have access to solutions of all the questions in the tutorial sheet 5, they are there on the A Plus Academy app, okay, and they are there in handwritten format so that you can quickly revise. Instead of watching a video, you can just quickly scroll down the document and compare with your answers. Okay, so I'm trying to focus on those challenging ones. Okay, so this one they're saying that show that the solution of this one is equal to. So this question is where you need to know how to derive the bus formula or the quadratic formula. And you should know that this. Alright, so let's solve this one. So the question is saying that show that the solution of this one is equal to this. So this one is why they want you to derive the formula for the quadratic formula. I mean, this is a question whereby they want you to show how this formula was obtained. Yes, you have to show the steps. I know that you are used to memorizing it, but it came from somewhere, and that somewhere where this formula came from is from this simple expression which we all know. So what we do is that we are going to use completing the square method. That method which we use when you're solving for x using completing the square method, it is the method that we are going to use to derive this one from this one. So if you remember how I solved the first questions, the way I was applying completing the square method, if you understood, then this will be a walkover for you. In fact, by just knowing that, you can pause the video and try to solve for x of using this expression. You land to this formula here. Right? So without any further ado, let's quickly solve this question. Alright, so we have ax power 2 plus bx plus c is equal to 0. So if you remember, I said whenever you have anything in front of x power 2, you need to divide through out, right? Then what have remained with this and this will cancel, right? We have x power 2 plus b over a. We are using completing the square method. And then I'll take this on the other side. I'm going to have x power 2 plus b over a x is equal to negative c a. So now, this is why we are going to get what's coming in front of x, which is b over a multiplied by 1 over 2, which is going to be b over 2a. Right? So I'm going to raise this to the power of 2, then add on this side and this side. So first let me write what I'm initially having. I'm initially having x power 2 plus b over a x, then I'll say plus, I'll add this one, b over 2a, but I'll raise it to a power of 2. Then a on this side, I'll say negative c over a. I'll say plus, I'm adding this one, but I'll raise it to the power of 2. To a power 2. Right? So since this and this are both raised to the power of 2, we can put them together, right, in the parentheses. So I have x plus b over 2a, right? And then don't forget power 2 is equal to negative c over a. So this one, let me try to simplify it. So if we raise it to the power of 2, what are we going to get? We are going to get b power 2 over 4a power 2. Right? Alright, so now listen, we're solving for x, right? And our job is to make x the subject. So first of all, I need to get rid of this power 2. So I will introduce, I'm going to introduce square root. Now before I even introduce square root, let me try to simplify this a little bit. So what I'm going to do is that I'll make this a single fraction. Then I'll say this into this. It will be negative 4, one a will cancel ac, right? This into this, it will be just 1. 1 times b power 2, it will be plus b power 2, right? So if I were to rewrite this again, I would say right now we have negative b ac plus b power 2 over 4a power 2. And on the other side, on the left side, I'm still having this. So now listen, I'm looking for x, right? And for me to solve for x, I need to introduce square roots on both sides. And whenever you introduce square roots on both sides, you automatically have plus or minus. Let me just write them properly now. So first of all, this power 2 and the square root will cancel. So a, I'm just going to remain with. So I'm going to remain with x plus b over 2a being equal to plus or minus, which came when we introduced the square root negative 4ac plus b power 2 over 4a power 2, right? Yeah, so I'm going to take this on the other side, and it's going to be x plus b over, my bad, I forgot. So we have x is equal to, so when we take this from the other side, it will be negative b over negative b over 2a plus or minus square root negative 4ac plus b power 2 over 4ac. I mean, not 4ac, 4a power 2. So I'm just running out of space. Let me just write this on a separate page. I continue from there. Alright, so let me try to evaluate this one a little bit, this part alone. So I'll say x is negative b over 2a, right? Plus or minus. So you know that this one can also be written as square root negative 4ac plus b power 2 over square root 4a power 2. Yeah, so what we're having here, so basically what we're having here is it's like this. This thing can also be written like this. Now what I'm going to do is that I can simplify the denominator. The denominator is simplifiable because negative b over 2a plus or minus. Here's how it is simplifiable, because this we are raising 4 and a power 2 to the square root. So basically it's like this. Square root of 4 it is what? Okay, look, what I'm having here on the denominator, I can also write it as square root of 4 times square root of a power 2. You get it, right? So I can simplify these two, because square root of 4 it is 2, and square root of a power 2, the power 2 and the square root will cancel, and I'll just remain with 2a. So that 2a which you see on the denominator in that formula which you've been memorizing your whole life, this is how it came. Okay, so this, I can simplify this into 2a. If you don't understand, just rewind. You rewind where I've explained from here to here. Okay, so square root, the numerator, see, plus b power 2. Right, and then, so instead of me writing this, I'll write this because I've showed you how we can simplify this, right? So I'll say over 2a. So now I'll make this a single, fraction over 2a. So 2a into this one, it is just 1. 1 times negative b, it is negative b, plus or minus. This into this, it is 1. 1 times the whole thing on the numerator, it's going to bring us the whole thing on the numerator. So now, have we reached on the, let's go back to the question again. So they want us to end up with something looking like this. This is the original question. Have you seen, like, we are almost there, right? Like, we are there. Now, if you look at under the square root here, b power 2 is coming first, negative 4ac is coming second. So your job is to just rearrange what's under the square root. Under the square root, then you are done. So this is how the formula was derived. So you've spent your whole life memorizing something which you don't even know where it came from. I hope you don't forget this. So I'll start this time with b power 2 minus 4ac over 2a. So in case in the exam you forget this formula and you know they will complete the square method, maybe like you know it deeply, you can just derive the formula. All you need to remember is this expression. You can be deriving this formula as long as you know completing the square method. Actually, me, that's what I do, especially in physics. Even when I was in my first year, physics related stuff, these formula courses which are drivable, most of them, I just used to drive them. I'll just remember the basic, like the fundamentals like this, then I'll be just driving them on the exam. And it's very easy to drive, like if you've practiced. So you find your friends are struggling to remember the formula, then you who knows how to drive, you're just driving them. Especially if you watch my physics videos, I'm more focused on making you that kind of a person who's able to drive. Okay, of course my videos cater, my lessons cater for both those who like memorizing formulas and those who like driving them. So I don't just teach how to memorize. If you are somebody who has the A Plus Academy app and you watch my video lessons there, you can see, especially the term 2 and term 3, that's why there are like a lot of formulas. You will see that I'll even show you how to drive those drivable formulas. And I'll tell you that this is easy to drive. I'll make it easy for you to drive. Okay, so make sure that you subscribe to A Plus Academy app. A Plus Academy. I'll put the link in the description or in the comment. Our app is now on Play Store, so you can download it and you'll find more videos there which you can watch at your own pace. The A Plus Academy app. It's actually the best app at CPU because it's the only app where you find not only the videos but also the documents, the solved documents and the studying documents, the lab reports, like everything that you need on your first year as an NS student. You'll find it there. Even the quizzes are now there, and we're introducing more features to make your learning journey enjoyable. So don't forget to download the A Plus Academy app. Right? So let me show you the last question. So for you guys who are on YouTube, this I think will be the last question I'm solving for you in tutorial sheet 5. I know the video is long, but another video is going to be recorded. So there will be part 2 video. This is part 1 video that you are watching here on YouTube. Part 2 video will be on the A Plus Academy app. And in case maybe you want to download it, I'll put the link in the description like I've said. And in the part 2 video, I'll continue solving. Like I'll solve, maybe I'll solve questions on part 2 video. I'll focus on those major questions. Like since tutorial sheet 5 is very big, and it can be so ridiculous and time consuming to record the whole thing, so I'll be just getting those challenging questions which I know that students can struggle to solve this. So on alpha and beta, I'll solve some, and on polynomials, application of quadratic equations, I'll solve, like I'll just combine them. Like on each part I'll get the challenging questions, okay, and I'll be explaining the same way I've been explaining throughout this video. So make sure that you download the A Plus Academy app, or you can contact me on the phone number which I'll put on the screen at the end of this video. Right, Plus app. This is where you access all the full videos. So what you just do is come here on videos and then click on term 1, term 2, or term 3. So let's say term 1. Then we offer all these courses: math, physics, chemistry, even biology. And then you find simplified videos. You just have to select the topic that you want. So like in this case, under functions, you're going to find more videos on functions, all these domain and range, all the concepts that we're applying, the composite functions. If you haven't understood everything that we've learned so far, that we're going to cover in the video, okay, so all these topics, okay, so all these topics have been taught. These are organized topics. Even if you are behind, you just need to watch them in order in which they are, then you catch up at the end of the day. And we have a lot of students who are watching these videos and they are really enjoying it. Okay, if you want, you can maybe choose, there is sets of numbers. You're going to find videos about it. Okay, but it's not only math, even these other courses we simplify as well. We've already taught all the NS syllabus has already been taught. Okay, if what you're looking for is chemistry, just choose CH110. You find the videos here. Okay, if it's introduction to chemistry, you find the videos. So all these topics have been taught. Alright, so it's not only these, even the solved tutorial sheets are also found on this app. So just come here on ma110. If you want the tutorial sheets that which will be solving, we've solved all these tutorial sheets already here for 2026. You'll find the tutorial sheet here. So make sure that you contact me there. I give you the A Plus Academy app and start learning and practicing with our solved materials.